Hi, my name is Shawn and today we will be covering amides. So let's start off with a quick joke to lighten the mood. So, why do people come to me for help in organic chemistry? Think about it. Because they have all kinds of problems.
Boo! You suck!
So now I'll provide an overview and rules of naming amides. So what are amides? So amides are derived from carboxylic acids, and amides contain a carbonyl group, which is C double-bond O group attached to a nitrogen group, and the two chains of an amide are joined together by a nitrogen atom. So in terms of naming amides, we want to number the parent chain, and it is a chain that contains the C double-bond O group, which is the carbonyl group, and the name always ends in amide. The other hydrocarbon chains that are attached to nitrogen that do not include the parent chain are substituents, and when they are substituents on the nitrogen, the name always begins with N. In terms of the properties of amides, they are mostly weak bases since they contain a nitrogen with a lone pair. Smaller amides are soluble in water because they have the ability to hydrogen bond with H2O molecules, and the more alkyl groups that are attached to nitrogen, the lower the boiling point and melting point will be since they lose hydrogens and lose the potential for hydrogen bonding. Now it's time for drawing and representing amides. So now we represent amides using chemical formulas. So here we have hexanamide. So in order to find the molecular formula, we have to count the number of each element. So here we can see we have 6 carbons. In terms of hydrogens, we have 13 hydrogens. We have 1 oxygen and 1 nitrogen, giving us a final molecular formula of C6H13NO. For expanded formula, we need to take into account each of the carbon bonds. So you have CH3, CH2, 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 CO, NH2 for final expanded formula. So now I'll be drawing amides using complete diagrams. So here we have our example, N-propyl 2-methylpropanamide. So first thing we want to do is draw the main chain, which consists of 3 carbons since it's prop. We have amide, which means there's a double bound oxygen on the first carbon. We have a methyl group on the second carbon. Then we have our nitrogen connected to our first carbon, and nitrogen is always connected to a hydrogen. Then we have a propyl substituent on the nitrogen, which consists of a 3-carbon chain. And from here on, we can draw all of our hydrogens to ensure each carbon meets 4 bonds. That was pretty easy, wasn't it? So now I'll be drawing amides using structural diagrams. So here we have an example, butanamide. So structural diagrams are very similar to complete diagrams, however, they're a little more condensed. So, since it's butanamide, we want to draw our main carbon chain, which is a 4-carbon chain since it's but. We'll draw our double-bound oxygen on the first carbon since it's amide. And we're going to draw the hydrogens beside each carbon to ensure each carbon has 4 equal bonds. So this is the structural diagram of butanamide. So now we'll be drawing amides using line diagrams. So here we have an example, N-ethyl 2,4,6-trimethyl decanoamide. So don't let the name scare you because it's pretty easy to draw. So let's start off by drawing our main carbon chain, which consists of 10 carbons since it's deca. Then we have a nitrogen connected. Then we have an ethyl substituent connected to the nitrogen, which is a 2-carbon chain. Then we're going to draw our double-bound oxygen on the first carbon since it's an amide. And then we're going to number a carbon chain. And we can see we have 3 methyl groups at the second carbon, the 4th carbon, and the 6th carbon. You can draw. And this is the line diagram of N-ethyl 2,4,6-trimethyl decanoamide. Now it's time for naming amides. So now I'll be naming amides using Arpac nomenclature. So here we have our amide. So first thing we want to do is number the parent chain starting with a double bound oxygen, which gives us the first name of but. Only the single bonds gives us the last name of ane. The double bound oxygen on the first carbon gives us 1 amide. Then we have some substituents connect to our nitrogen, such as an N-methyl group and an N-ethyl group. And we can drop the E in ane and drop the 1 in 1 amide, put all of this in alphabetical order to give us a final name of N-ethyl, N-methyl, butanamide. Alright, let's move on to organic reactions of amide. So now we're going to look at the organic reactions of the synthesis of amides. So here we have ethanoic acid and methanamine. So since we know when a carboxylic acid and an amine react, it is a condensation reaction because they produce a larger organic molecule known as an amide and water. So in terms of this reaction, the products will be N-methyl ethanamide and water. So now we will be drawing out these products using structural diagrams. So to repeat, our products are N-methyl ethanamide and water for this condensation reaction of ethanoic acid and methanamine. So now let's look at organic reactions involving amides. So here we have N-methyl propionamide plus water with a sulfuric acid and heat catalyst. So we know this is a hydrolysis reaction because when water is added to a large organic molecule, it cleaves into two, and in this case it would form a carboxylic acid and an amine. So in terms of this reaction, the products would be propanoic acid and methanamine. So let's begin to draw out our products using a structural diagram. So once again, the hydrolysis reaction between N-methyl propionamide plus water with a sulfuric acid and heat catalyst produces propanoic acid and methanamine. So who's ready for some organic chemistry practice? So I'll be giving you guys some questions based on the concepts covered in this video, and you guys would pause the video on the question, do the question, then play the video again to find out the answer to the questions. Thank you for watching, and be sure to tune in next time where hopefully my organic chemistry jokes get better.